Okay, performance athletics. Things that we know that are fairly logical, that we are going to improve over time, and the time is likely to be in years. Bits that might seem obvious but people tend to forget. If you're doing something that is measured in time, you're likely to get a negative gradient because the world record times will fall as people improve. Whereas if you're doing something in distance, so discus, javelin, high jump, long jump, the world record will increase because people will be getting longer distances, higher heights. It doesn't always follow a predictable pattern. Certain world records will stand for years and years and years. So if you look at something like a 100-metre sprint, then the records that Usain Bolt put in are massively ahead of the sort of predictions of times. Things could also drop again if you're just looking at achievements for something like London Marathon or Olympics rather than records. And so you could have drug bans so that when something's cleaned up its act, then things drop again. But a world record or an Olympic record will not drop. The time needed for a gold may drop. Okay, phases of the moon. This one gives us some information. Sun always eliminates half the moon. So that's always the bit that is facing towards the Earth. The sunlight never hits the other side. However, the amount of moon that we see varies as things change during a lunar cycle. A lunar cycle is actually 29.5 days. So you're expecting a value for your frequency of 360 over about 29.5. So it should give you a period of about 29.5. The other key thing to remember is this one is trig, and trig in AS uses degrees. So double check that your calculator is set up in degrees and not radians, because it will be in radians if you've been doing either calculus or comprehension. So we are told that we are observing a fraction of the moon. So this fraction of the moon potentially is a decimal, potentially is a fraction, potentially is a percentage, and that is going to impact on the amplitude of our equation. And we model the data using a trig function. So this could be cos, it could be sine. So what we're going to be expecting is y equals a either sine or cos x and that will be, we'll call that frequency. So this amplitude is either likely to be 50 if we're measuring in percent, or is likely to be 0.5 if we're doing either fractions or decimals. This frequency is going to be 360 divided by the period. So if you need to find what the period is, you can do 360 divided by the frequency to get the period. And that is, the period is likely to be in the region of 29.5. If they've grouped these two together, this will tell you how many days the cycle's been shifted by. So it may not, if we were looking at a sine graph, it would normally start halfway through the lunar cycle, so this one or this one, and this plus t bit will show us how many days we've shifted in either direction. This value of c is the bit that has translated your graph up. So it's likely to be 50 if we're dealing in percent, or it's going to be 0.5 or a half if we're dealing in a fraction. So the transformations that we're going to be dealing with will be a stretch of a in the y direction, a stretch of 1 over f in the x direction, a translation of minus t over c this phases of the moon bit, we're likely to be looking at what happens on certain days. The bit we may have to be careful of is if it asks us for 0 being the first of the month, just remembering that something like t equals 10 will then be the 11th of the month because you've got that initial +1.